Hi students, last class I discussed about distance time graph for uniform motion. From the graph, we understood that the straight line represents object moving in uniform motion. If you draw distance time graph and the graph represents a straight line, so that straight line motion tells about the object is moving with uniform or it's moving with uniform speed. From this graph, we calculated the velocity by using these details in this graph. Today, I would like to discuss distance time graph for non-uniform motion. Let's see what is non-uniform motion. If an object covered unequal distances in equal intervals of time is known as non-uniform motion. So this is the definition of non-uniform motion, and we need to represent this in distance time graph. Recall the definition again. If an object covered unequal distances in equal intervals of time, so this type of motion is known as non-uniform motion. To draw distance time graph for the non-uniform motion, I have selected certain details from the NCERT table 8.2. So this is the distance traveled by a car at regular intervals of time. Now see here, the time intervals are equally divided: 0, 2, 4, 6, 8, 10, 12. Time interval is same, but distance in meters, this is different. So according to definition, if an object covers unequal distances in equal intervals of time. Now by using these details, we will plot distance time graph. So the distance is taken along the y-axis and the time is always, we should take time always in x-axis to draw distance time graphs. Now here the time is in seconds and the distance in meters. According to given details, try to plot the graph. At time is 0 seconds, so the distance also 0. It means the point comes at here. So I can put a point at there. And if the time is 2 seconds, the distance in 1 meter. You can take time is at 2 seconds. For the second point, it means here the time is 2 seconds, but the distance is 1 meter. Now on the y-axis, I have taken scale 1 centimeter. It means each block we call as 1 centimeter. 1 centimeter equal to 2 meter. On x-axis, 1 centimeter equal to 1 second. So on y-axis I have taken 2, 4, 6, 8 like that, but we got at here at a time equal to 2 seconds, the distance is 1 meter. It means at time is equal to 2 seconds, distance is 1 meter. I will take exactly at the middle as 1. So I make a mark at here. So this is the second one. For the third one, when the time equal to 4 seconds, the distance covered in 4 meter. Means at time equal to 4, the distance covered 4. So please mark it here. When time equal to 6 seconds, the distance covered 9 meter. when time equal to 6 second and distance covered 9 meter. So 9 is exactly at the middle in between 8 and 10. When time equal to 8 second, distance covered is 16 meters. 8 is here and 16 is at here. So make intersection point clearly. When time equal to 10 second, distance covered 25. So when time equal to 10, distance covered 25. I have taken up to 24. Yeah, you can keep it there for a moment. So I am skipping the last value since it goes out of my graph, but you do that point in your graph. Now join these points with the free hand. It means don't use scale, just connect these points with pencil with the free hand. That's why. So now we can get curve just like some shape. Okay, now here we observe this line is not a straight line. So this line just like curve. So non-linear motion distance time graphs will be any shape other than the straight line. It depends upon the distance versus time. So that's why non-uniform motion graphical representation is not straight line. So by using this graph, we can calculate the average speed or the average velocity by using same as like we did in the uniform motion. Yeah, so this is how to draw a distance time graph for non-uniform motion.